This is Dr. Shivnag Reddy and you are going to see the Applied Physics Syllabus for the first B.Tech. Our regulations are 22, which is going to start from academic year 22-23. Presently we are going to see the two parts. First one is the theory, second one is the lab. We have mainly 5 units. First one is the wave optics, second one is a quantum physics and solids, third one is a semiconductors and devices, fourth one is a nanotechnology, and a fifth unit is a lasers and fiber optics. When come to the exam, each unit will be given as a equal weightage. Wave optics we have mainly three parts: interference, diffraction and polarization. So as the part of interference, we have Huygens principle, superposition of waves, interference, basic definitions and the conditions for the interference. Along with it, interference in thin films by reflection and the Newton rings, theory and experiments we have to study. When come to the diffraction, basically we have to see the definition of diffraction, then types of the diffraction, Fresnel and Fraunhofer. Then we will Fraunhofer diffraction at a single slit. Then we will see about the plane diffraction gratings and resolving power of the grating. When come to the third part of the first unit, that is nothing but a polarization. We have to see what is the polarization and polarization by reflections by studying a Brewster's law and polarization by double refraction. Based on that, we will study about the Nicol prism. In this Nicol's prism, we will study about the construction, working and its applications. So that concludes the first unit, which is a wave optics. So then we will move to the second unit. Mainly it consists of two parts. One part is a quantum physics and the second part is the solids. So in the quantum physics, we will start with our black body radiations and their issues and how Planck's law resolved the things. Then we have the de Broglie hypothesis about matter waves. Then the experimental proof of de Broglie waves. Then we will see Heisenberg uncertainty principle qualitatively. Then we will see what is a wave function and how this wave function play the key role in the quantum mechanics. Along with it, time independent Schrodinger wave equation, and as the part of the applications we will see a particle in one-dimensional potential box. When come to the second part, that is nothing but the solids. In that solids we will see about free electron theory, that is nothing but Drude-Lorentz classical free electron theory and a Sommerfeld quantum free electron theory. Then we will see what are the limitations of them and merits. So to overcome the limitations of those two models, we will introduce a Bloch function along with Bloch theorem where we will deal with periodic potentials, and based on it we will study about Kronig-Penney model. As an integral part of it, we will study effective mass of the electron and how the bands in a solids are formed, and then based on the energy bands we will classify the materials into conductors, semiconductors and insulators, and after that we will come to the next unit, that is a semiconductors and devices. In this semiconductors we will study about what is a semiconductor and the types of semiconductors like intrinsic and extrinsic semiconductors and how the energy band diagrams will be them, and then we will see about the Hall effect significance and its applications. Then we will see the direct and indirect band gap semiconductors and applications. As the part of it we will see what is p-n junction diode and VI characteristics. Then we will go for the Zener diode, bipolar junction transistor, this construction, working and characterization of light emitting diode, photodiode and solar cell. So which concludes the unit 3. When come to the unit 4, it is a nanotechnology based. Basically we have basic terminology about what is nanoscale, then what do you mean by quantum confinement, surface to volume ratio. Up to here this is the basic terminology related to the nanomaterials and technology. When come to the next part, we have the fabrication of the nanomaterials based on bottom-up fabrication and top-down fabrication. So in the bottom-up fabrication, we have sol gel process and combustion methods. Then when come to the top down fabrication, we have after the ball milling, we have a physical vapor deposition method, chemical vapor deposition methods. After the fabrication, we have a characterization techniques. One is X-ray diffraction, then scanning electron microscopy and a transmission electron microscopy. And the final concept is the application of the nanomaterials in a different fields. The final chapter in the theory, that is a laser and fiber optics. So in this laser, we will see what is a laser and what do you mean by absorption, spontaneous emission and stimulated emission. Then we will see about the Einstein coefficients and their relations. Then we will see what is the difference between a laser light and ordinary light. Then we will see the construction of the lasers, what are the important components of the lasers, like active medium, pumping source, optical resonator. Then we will see the construction and working principle of different types of the lasers. In our present chapter, we will see NdArc laser, helium neon laser and semiconductor laser. Then we will focus on different field applications of the lasers. As the second part of the unit 5, we have fiber optics, introductions to fiber optics. Then what is the advantage compared to normal total internal reflection. Then we will see the construction of optical fibers. In that construction of the optical fibers, we will see what do you mean by acceptance angle and a numerical aperture, the classification of the optical fibers as a step index and graded index fiber. Then we will see whenever we are transmitting the signal to the optical fiber, what are the typical losses happen in the optical fiber. And when come to the optical fiber for the communication system, what is the main advantage and how use them. Then finally we will see what are the applications of the optical fiber in a communication systems, in a medicine and in other fields. Then when come to the textbooks, recommended book is Avadhanulu, which consists of almost all the engineering syllabus, and Satyendra Sharma and Jyotsna Sharma, and a textbook of engineering physics by Palaniswamy. These are the books. You can take any one book and you can find all the content related to it. And when come to applied physics laboratory, we have 12 experiments. In the 12 experiments, we have to perform any 8 experiments. Wave optics, we have Newton's ring experiment, which we study in theory. Then diffraction grating, determination of a wavelength of monochromatic source, and a single slit diffraction using lasers also. We have determination of wavelength of the laser light. Then dispersive power of the material of the prism by minimum deviation method. So in this we will do three experiments mainly based on wave optics. When come to the next unit, we have only one experiment related to quantum mechanics, that is nothing but a photoelectric effect. By using photoelectric effect, we are going to calculate the Planck's constant and the work function of the. Then when come to next chapter, especially semiconductors, we have other experiments like a light emitting diode, laser diode, PN junction diode, GNR diode, solar cell. In all this we will see and study the voltage current characteristics. Apart from it, and from the same semiconductors, we have bipolar junction transistors. In that we have to study CE, CB, CC configurations in input output characteristics. Then we have to measure energy band gap of a germanium semiconducting material based on availability of in our lab. Optical fiber, we have the acceptance angle and a numerical aperture of a optical fiber, bending losses of optical fiber, then understanding the method of least square by as a torsional pendulum as an example. So for this we have generally we will provide the manual for the lab, and if you require additional information you can consult the